Hey everybody, this is a quick video to show how to do the participation activity for Econ 170, Public Economics and Regulations. We are reviewing the Cournot model. Just to remind you, the Cournot model is an old model from the late 1800s, looking at firms in a duopoly or a small oligopoly, right? Duopoly is just an oligopoly with two firms. And what we want to look at here is Cournot uses quantity as the strategy that these firms can use to maximize profits in this market without much competition. So we're going to see downward sloping demand and marginal revenue curves. We're going to see an assumption of a flat marginal cost curve at $40. And what we want to do in this for this assignment and for this activity is to calculate and graph the demand and marginal revenue curves and the Q1 for our firm, the quantity that our firm 1 would produce given the quantity firm 2 produces in a couple different cases. And then just graph that best reply function that's in the text and in the slides, just to remind ourselves what it means and sort of re-emphasize that Nash equilibrium that we get there. Everything in this participation activity is in the slides and in the textbook. It's, pages 120 to 123 or so. You don't have to derive the best reply function. It's given in the book and in the slides, and I'll give it to you all right here. But let's go ahead and get started. And I'm going to start this out because there is a certain amount of algebra on using the DotCam, and then I think we'll probably graph it up on the whiteboard, but maybe not. We'll see how it goes. So let's get after it. Okay. So let's get started with this Cournot model activity. So part 1 says, graph the market for goods and services supplied by two firms in an oligopoly, as indicated in figure 4.4, when the inverse demand function is P equals 100 minus Q, and marginal revenue is 100 minus 2Q. And because the market has only two firms, that market quantity is going to break down into P equals 100 minus Q1 minus Q2. And this is exactly like what we see in the book. I'm going to go ahead and flip that in there for y'all right here on page 122. This is also in the slides. This figure 4.4, this Cournot model, shows the market demand, which is if you set P equal to 0 or Q equal to 0, we get 100 to 100. That's how you find the endpoints for that demand curve. And what we want to do is calculate the demand and marginal revenue for firm 1 if firm 2 produces 10 or 40. And so the 10 example is here, and then the 41, you have to calculate that yourself, but it really is just straightforward algebra. So let's get after it. So we start out with our first condition is we want to remember our marginal cost is equal to 40, and that's constant. And that'll help us get our quantities demanded for our firms. We want to start out with Q2 is equal to 10. So that means that the price is going to be equal to 100 minus Q1 minus 10. And we can solve for the inverse demand function now. And it's just going to be P equals 100 minus 10, or 90 minus Q1. And I want to kind of backtrack real quick here and remind everybody, we also had the profit functions for each firm, which was just going to be the price times Q1 minus that marginal cost of $40 times Q1, and the same for firm 2, just using their quantities. So we're assuming that the firms face the same quantities, and then they're just going to profit maximize. But when we go through and we add in, we can go in and insert this formula for price in here. And so if I wanted to find the profit for firm 1, it's going to be a function of price, which is 100 minus Q1 minus Q2 times Q1 minus 40 Q1. And so what we see here is that the price is a function of the market share that Q1 and Q2 split. And that means that firm one's profits are a function of that market share. And that's one of the important things about this Cournot model is that interdependence, right? The idea that firm one's profits are in part dependent on firm two's market share. So that's just a little backup reminder of what's going on there. Let's get back into finding the demanded marginal revenue curve for firm one if firm two produces 10. So now we have the inverse demand function. We can also solve that for their quantity, right? Q1 is going to be equal to 90 minus P. And then if we want to, if the marginal revenue up here is 100 minus 2Q, the marginal revenue in this case is going to be equal to 90 minus 2Q1. And we can also think about the actual revenue being equal to 90 minus Q1 times Q1, because that's the price that our firm faces. So that helps us see how we kind of derive those things. So now we want to find the equilibrium quantity. So if we want to find what firm one is going to produce, we want to set marginal revenue equal to marginal cost. So marginal revenue equal to marginal cost is going to be that $40 equal to 90 minus 2Q1. I'm going to add 2Q1 to both sides, and then I'm going to subtract 40 from both sides. And I get 2Q1 equals 50, divide by 2, and I get Q1 equals 25. And if you go back and look at the slides in the book, that's what we see. That's sort of what we expect. So I'm going to kind of keep track of all my favorite things here. Well, that's very light. That is not satisfying at all. Let's try this. Right? Okay, so now I've got my inverse demand function, my demand function, and my marginal revenue curve. If Q2 is equal to 10. Now the second part says, part 1 says, part B, 1B says, what if Q2 is equal to 40? This is the one that's not in the book, but now that we know how to solve it, we can go from there, right? So we're going to say, okay, well that means that P equals 100 minus Q1 minus 40. So P equals 100 minus 40, or 60 minus Q1 is the remaining market share and the demand curve for firm 1 if firm 2 takes up 40% of the market share. The inverse of that is going to be that Q1 is equal to 60 minus P, and then the marginal revenue curve is going to be that 60 minus 2Q1. The revenue is going to be that 60 minus Q1 times Q1. And then again, marginal revenue equal to marginal cost. So we have 40 is equal to 60 minus 2Q1. Move that over and then subtract both sides by 40 to get, so if I add 2Q1, it comes up over here, subtract 40 from both sides, I end up with 2Q1 is equal to 20, or Q1 is equal to 10. So those are going to be the equilibrium quantities that our firm 1 is going to produce in each of these cases. And that's what we want to graph. And again, we want it to look just like what we saw in that figure. And so what I would go ahead and do is, let's see, can you see? Okay, so I'm going to go ahead and do the graphs up here for a handful of reasons. So what we want to do is graph the market demand. You don't have to, I guess, graph the market demand, but we want to go ahead and graph the demand curve and marginal revenue curve for firm 1 in those 2 cases that we looked at, and then find out what the quantity they would choose would be. So we've got our price up here, and we're just going to be looking at the quantity that the first firm generates, and I'm going to try and keep my color scheme consistent. So for market demand, I'm going to put there it is. Market demand, remember, is given by the inverse demand function is P equals 100 minus Q, which means if Q is 0, P is 100. And if we get the actual demand function, we have the same case where if P is 0, Q is 100. So that means that we can draw our demand curve as being a straight line connecting those 2 points. And you don't have to do all this. I'm just going ahead and recreating the graph in the book. So that's going to be the whole market demand, right? That large uppercase Q. So now we want to go ahead and look at the demand function for firm 1 when firm 2, if Q2 is 10, then firm 1's inverse demand function was 90 minus Q1, which we can translate into Q1 equals 90 minus P, which tells us that that demand curve is going to be right here. And I'm going to graph it in blue because I calculated it in blue, and I feel like that just is nice. Just makes sense. So that is the demand for firm 1, given that, sorry, this is driving me crazy, given that firm 2 produces Q1. So we're going to call that's Q1 equals 90 minus P, right? And then the marginal revenue curve is given by the equation. Its marginal revenue is equal to 90 minus 2Q1. And so that's going to look like this. So we've got that marginal revenue is equal to 90 minus 2Q1. So if we set marginal revenue, if we set the Q equal to 0, we get a marginal revenue value of 90 minus 2 times 0 is just marginal revenue of 90. Sorry, marginal revenue of 90. So it'll start up here, which makes sense. That's how the marginal revenue curve usually it goes. And then if we set the marginal revenue to 90, then we get 90 minus 2Q1, or 2Q1 equals 90, Q1 equals 45. And so we want a marginal revenue curve that's going to come down about like this. Not quite to scale, but let's assume it is. Okay. And then we had our marginal cost curve, which is 40, which is going to be about like that. And then we had our equilibrium at this level, which was, oof, did I draw it right? I might not have. The scale's going to bite me in the rear. Yeah, no, it's going to work. Okay. Marginal revenue equal to marginal cost. Drop it down at 25, which we solved for, right? By setting that marginal revenue equal to marginal cost, we had 40 equals 90 minus 2Q1. 2Q1 equals 6. Gee, that's not right. Oh, yeah, that's not right. 2Q1 equals 50. I've been making videos all day. I'm getting a little punch drunk. I apologize, y'all. I'm going to tighten it up for the last bit of the video, but I'm not going to edit that out because it takes way too much time. So let's just roll into the second one, okay? So the second problem says, okay, what if Q2 is actually 40? And this is the one that's not in the book that we had to kind of figure it out ourselves, right? Which is awesome. We love figuring things out ourselves. So now we have the inverse demand function is P equals 100 minus Q1 minus Q2, which is 40. And that's what you want to remember, is we're always starting with that inverse demand function of P equals 100 minus Q, P equals 100 minus Q1 minus Q2. And this was the monopoly condition. And then that's the duopoly condition. So we're always kind of keeping that in mind. So now I've got my Q2 is equal to 40, so I can solve for firm 1's inverse demand function. That's going to be P equals 100 minus 40 is 60 minus Q1. So that's going to mean that my demand curve is going to start and end at 60. And that's a function of what would happen if I set Q to 0 and solve for P, or if I set P to 0 and solve for Q. Either way, I'm going to get 60. So let's find where that would go, somewhere about there and there. I'll graph that demand curve. It's going to get nice and crowded in here. And then, ooh, that is not the cutest, but we're going to just let it ride. And then we want to go ahead and solve for the, let's use this one, solve for the marginal revenue curve. So the marginal revenue is equal to 60 minus 2Q1. And so we can solve for if marginal revenue, if Q is equal to 0, marginal revenue is going to be equal to 60. And if marginal revenue is equal to 60, then Q will be equal to 30. See that? So that's going to be a marginal revenue curve that goes right about like that. Oh, we're so wobbly. Let's try that out again. I can do better than that. Let's try it more like, and that would be 30. And then we have to set marginal revenue equal to marginal cost. In this case, marginal cost is 40. And marginal revenue is 60 minus 2Q1. 2Q1 equals 20, which means Q1 is going to equal 10, which looks about right. When we drop this intersection point down, that's our equilibrium. A little bit crowded, but you get a sense of it there. If you didn't graph it for your participation activity, I don't think... Oh yeah, I do ask you to graph the market supply by two firms as indicated in 4.4, where the inverse demand function is given. So, you know, I think it's a good exercise to go through and graph these things because it's a good practice to get a sense of how this works, what this means, and what we're really talking about. We're talking about the same thing we've been talking about all through this oligopoly chapter. How if we have a small market with not a lot of firms, firms have an incentive to behave competitively or not competitively, and that competition can look a lot of different ways. It can look like choosing quantities, it can look like choosing prices, it can look like innovation or less innovation, it can look like a lot of things. Last step we want to do is graph the best reply functions, and this is super simple. It is given in the book again. It's just those best reply functions that they calculated that we didn't even bother calculating because that's not the most important thing. The most important thing is having an understanding of what we're looking at. So, right, the best reply functions are going to be They start over here on page 123, and they're in the slides, figure 4.5 and 4.6. 4.6 has those two best reply functions, and what it's looking at there is the two quantities that the two firms could choose as a function of what the other firm does. So we'll look at the quantity that firm 1 produces and the quantity that firm 2 produces, and that gives us those best reply functions. And we want to remember that the best reply functions are, for Q1, it's 30 minus 0.5 Q2, and for Q2, it's 30 minus 0.5 Q1. And again, we see that interdependence. Q1's best reply is a quantity. Firm 1's best reply is a quantity based on what firm 2 picked. So we can, again, solve for the endpoints by solving for 0 in these cases. So they're going to be parallel. So if I set Q1 equal to 0, that gives me 30 minus 0.5 Q2. 0.5 Q2 equals 30. Q2 equals 60. On the other hand, if I set Q1 equal to 30 minus 0.5 times 0, that's going to give me a Q1 of 30. And so that gives me the endpoints on this graph, right? So I'm going to go up to for firm 1, if firm 2 picks 60, they'll pick 30 and vice versa. And if we reverse the numbers, we get the exact same, right? These are parallel situations. So we find it for the other firm, we'll find the exact same scenario. So this will be the best reply function for the other firm. And where they intersect is that Nash equilibrium. It's an equilibrium where neither firm has an incentive to change. So if we check their math, the problem gives us that the equilibrium occurs at, or the book gives us the equilibrium occurs at 20 and 20. You can go in and check that, right? Q1 equal to 30 minus 0.5 times 20. 0.5 times 20 gives us 30 minus 10. Q1 equals 20. So if Q2 picks 20, Q1 should pick 20. We can go through and do the same thing the other way. We'll see it's the same. And so that's going to be that profit maximizing quantity for both firms. Sound good? Hopefully. And you can go in and try different things. You can go through and calculate the profits for this firm. We know that the profit function is given as a function of PQ1 minus marginal cost of 40. Just put that in there. 40 Q1, and P is equal to 100 minus Q1 minus Q2. If we go ahead and set Q1 equal to 20, we get the profit for firm 1 is equal to 100 minus Q1 minus 20 times Q1 minus 40 Q1. That will give us 80 minus Q1 times Q1 minus 40 Q1. And if we insert our 20 into there, we get 80 minus 20 is 60 times 20 minus 40 times 20 gives us a total profit of $400. So you can go through and double check that. I think I might have gone off the camera there a little bit. And the book has some notes in the footnotes about how to solve these problems, that kind of thing. I just want you to get a sense of the strategy associated with this and the interdependence. That's the most important thing. And have a sense of how it all goes together. So let me know what questions you have. Make sure you get this participation activity turned in, and I hope you have a great rest of the day. Take care, everybody.